Architectural Builder's Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
Okay, so you're working on a need for some pivots.
I'm sorry?
What are you working on, a need for pivots?
Yes, that's very specific. It's a door for a cabinet that is going to be, the door is going to be made of a tambour, which is 1 1/8 thick, and it's going to be applied to a 3/4 inch plywood to create the door. So that's going to be 1 7/8 inches thick door. It's 60 inches wide, 25 inches tall. So not so much weight, but because of its thickness, I can't use any sort of cabinet hinge, a European hinge. I am assuming, I'm pretty sure that I'm going to be having to use a pivot hinge. I've used the Deltanas before. I like them a lot, but I wanted to make sure that is appropriate for this situation for a door that's 1 7/8 inches thick, essentially.
Well, I don't see why it wouldn't be. You're going to want that. You've got a couple of pieces of material that are going to be probably glued together. You have to make sure you're into solid material when you're mortising it.
Yeah, that's what I was, exactly the same thing. I had the same thought. I could probably frame the door if I have to. I don't know I'm not making the tambour myself. This client is supplying it, so I'm a little bit hesitant about that. 4 doors in a row. They're oddly stacked. They're like 16 inches and 13, and 15 and 16. So I'm assuming that's because they want the cut to be at the full timbre, at the full profile of each timbre. Will I have to have a released back on the pivot side on all these?
Well, you have to have it released, or you mean relieved?
Like I round over in the corners, the hinge side, so the door is pivoted.
Depends on where the vertical axis of pivoting is. Is it measured off the face of the door at some dimension?
Well, if my whole door is going to be 1 7/8, and the Deltana one is 1 3/4, I believe, isn't it? Oh, it's 1 7/8, but that's to the very point. So I'm going to have to have it. I have to have the pivot point outside the door, into the room.
Okay.
So I guess we're just going to find out by try and error whether it has to be released in that back corner, right?
I don't think you're going to have to radius or bullnose it at all. If your pivot point is measured off the face of the door in the sense that the vertical axis of pivoting is offset from the face of the door, I don't see why you'd have to.
Okay. It'll sit within like an 1/8 inch next to the next door, and they'll both operate.
What you should do is put this all into AutoCAD so that there's no confusion.
No. I do SketchUp, so I can do it in SketchUp probably.
Well, I'm not familiar with SketchUp, but I would think that you can rotate, and I would think that you can rotate an object in SketchUp. I would think you can. I could do it for you. Place the order, and I'll tell you where to put the pivot point. It would be very quick to do.
No, okay, that's cool. That's a nice little thing. So, you have these in stock in brass, or in polished brass?
What? I'm not sure. Are we talking about the PH?
PH 40, I think, is appropriate.
Yeah, those are kept on hand, sure.
Okay, and then do you have it also in the antique?
Antique brass? Probably, yes.
All right, so I need to price those then, so I can if I get this job, then you'll get this job.
And if I get the job, I will do the AutoCAD work.
That sounds like a deal and a half.
Yeah. So you're about $72 for the pivot. Well, polished brass is $71. Antique brass, about $72.
Okay, so
it's a big pivot.
Yeah, I mean, do you have another hinge in your arsenal to do this?
Well, do you want a hinge or do you want a pivot?
I need to do. I'm open. If I need to open this cabinet door, it's a service station and restaurant, and it's going to be these big doors. I didn't think any hinge that I knew of would do it comfortably.
But what do you need to do? You need to just hang
open
some
this because it's almost 2 inches thick. They need to open. They have 4 doors next to each other, and then you should just open 90 degrees each.
Is the design of the door something that would prevent you from using sauce hinges?
No, I haven't. I didn't think about using sauce hinges. The cabinet can be a simple lower cabinet, so it's going to be 3/4 inch plywood construction. Sauce hinges of that scale are usually a little heavier, right? There's no internal face frame. Like there's not, so sauce hinge we have to have it. Sauce hinge, this is going to be door to door, right?
Oh, you know. Well, I don't know. I don't know. I've not seen your sketch.
I'll tell you now. It's going to be a fairly much like a lower kitchen cabinet. So it's going to be a door to a door to a door to a door. Four doors across, 1/8 inch reveal between them. That's how it was drawn by these guys. Yeah,
you're definitely going to need to have your mounting to the sill or whatever is at the bottom, and then up vertically at the header.
That's how I saw it too. They didn't know that at all when they sent me the drawings. I asked them. They said, you need something. You need a special hinge for that. So anyway.
How heavy are these doors?
I don't imagine they can be that heavy. I mean, if you have a 70 pounds per hinge, right? Per door.
Pivot.
Per pivot? Well, I mean per pair of pivots, right?
Well, yeah, the top pivot doesn't hold much of
right,
weight.
Yeah. So 70 pounds, I'm sure it's going to be fine.
So, but how heavy are they going to be?
I don't have an actual number yet because I'm not supplying the pivot. I'm not supplying the tambour that they're putting on this. I'll just once they give it to me, I'll make it into a door.
Yeah. It sounds like it's going to be pretty light, so you should probably.
Yeah, and that's what I'm saying. I mean, it's only 16 inches wide and 24 inches tall. It can't,
16.
It can't be. If it was solid MDF, it wouldn't be that heavy.
Did you say 16?
16 inches wide and 24 inches tall.
I'm really familiar, obviously, with MDF. I mean, it's not light, but you've got a tiny piece there. So I would look at the PH35. It's just. Are you going to put a banding around your MDF of hardwood?
Probably on the 3/4 piece.
Yeah, you're definitely going to have to put a banding around that because you want mortise to the end of the MDF. MDF is dreadful. I've done a lot of CNC machining on it, and it's it's got a hard outside surface, but you get into it and it's really no longer.
Oh no, it's terrible for screws. But in this case, I'm sorry, just so you understand, I would probably make the backer piece out of a veneer core maple plywood, and then edge band that just for clean edges. But I would mount. I honestly don't know what how this tambour is going to come to me, but it's going to be it's going to be applied. So it's going to be glued to a 3/4 inch panel to create a 1 7/8 inch total thickness. So
I would think it's going to come in a roll. Screwing to the edge of plywood, I don't have a lot of experience with, but I think the PH35s are going to be well within your range. The real problem, though, is your legs got to be centered under the 3/4 MDF area or your veneer core. And as a result, you may need the bigger pivot just to get your pivoting access out.
Because the 35 is only 1 1/4 inch, right? Actually, it's not even. That's the total.
So it's going to be actually 5/16. So it's going to be. Let's see here. That's 5. Let's see. So it's going to be 1.625 minus 0.3125. Yeah, inch and 5/16. So it's, I think you got to go with the bigger pivot just to be able to get past. Get under the veneer core and get the pivot point past the applied.
And your PH60 has the circular gear in it, right?
No, PH60 doesn't have any sort of gear.
Oh, well, it seems like it was the same dimensions, wasn't it? Or maybe it was a...
PH60 is... Oh, you mean the threaded spindle? Yeah. It's rated for a much heavier load.
A ball bearing interior insert, right?
It's got an anti-friction disc in it. Yeah.
Okay, that's the difference.
Dimensionally, it might be the same. But it's a lot.
That's why. It seems like I don't have it up in my pages here, but I thought it was the same dimension. But I thought it had that barrel sort of ball bearings.
No ball bearings. But it's a commercial application, and you're not going to see hardly any of this once you're installed. So you could make an argument to go with a heavier pivot because you want it to last. Not a year after the warranty's up, but a decade.
Right.
5 decades.
Yeah. And that's you're talking about going to the 60 instead of the 40.
Well,
I mean, the 40 seems to me like, I think the 40 is going to work fine. It's a solid glass.
Yeah.
It's a high quality unit. I mean, I've used these before.
It is. Yeah.
Okay, all right. So, okay. And your name again, I'm sorry.
That's okay. My name is Richard.
Richard. Okay, Richard. So we had 72, or 71, doesn't matter, each one. You have them basically in stock, pricing to get to New York?
Freight, maybe $20, something like that.
Okay. All right, so we're looking at okay, that's not bad. That's all seems fine. Is there a particular number I call you and yours, or you're the only one on this 844-809?
Any of us here can take the order, call back, the same number, ask for me, anyone in sales. But by all means, ask for me. I'd be happy to push it through.
All right, that's great. I'm going to see what they do with this job, and hopefully I get it. And like I said, then you'll get it. Thanks,
awesome.
sir.
Thank you very much. Bye-bye.
Thank you.
Architectural Builders Supply hopes you have enjoyed this program. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Let's add on to what the client was talking to us about in terms of his application. So here's our origin, and I'm going to draw... It sounded like the door was going to be 1 7/8 wide, so let's start with a line at our origin. But except I'm going to come in 1/16 of an inch. And what I have here is my snapping is 1/16 of an inch. So the major lines are 1/4 inch, so 1/16, 1/8, 3/16, 1/4. So from our origin, I'm going to come in 1/16 here, and then I'll draw another door to the left side. So let's go here, let's go 16. Let's come up 1 7/8 at 90 degree. Let's come out to 16. Let's come back down. Great. Okay. Oops. Okay. Let's take this object. Let's copy. That should be a... Got 2 copies here, unfortunately. Let's clean it up. Okay, so now what I'm going to want to do is, well, let's do this. Let's copy, just so that we have an entire look here. Okay, so that's what the client's got going, and we can take we'll take our origin and we're gonna move it out, but for right now, we'll leave it there. So pair of doors. It sounded like there was going to be 1/8 of an inch between the two, so let's do this. Let's take all of this, and let's group it. Let's take all of this one. Let's group it. Grouping will be important when we go to rotate it. Okay, so now let's take a look at our PH40 that the client was talking about. And let's look at their what they provide as a template. So the important thing is that the 5/8 is going to need to be under his core, his veneer core. So he's going to have tambour board, inch and 1/8 tambour board over 3/4 veneer core. So let's go back to our drawing and just let's bring a line. Inch and 1/8 here. And all this line is going to do is give me a reference point of where our veneer core is. And taking a look at the template, I'm gonna grab that, and I'm going to move it over onto another screen so I can see it at all times. Let's say that the client's actually, yeah, it's our origin. Okay, I'm now going to take our origin and just move it because I don't need to have it there. And let's just say that he's going to prep this so that the pivot is flush to the outside. It doesn't have to be, but we'll just draw it that way. And yeah, so I think of the 5/8 dimension here, we're going to need that component, which is going to be 1 5/16. Let's give ourselves a 1 5/16 reference line. No, it's not going to work. Let's do this. Let's rotate this. So because this is going to be 5/16 from the edge because it's 5/8 wide. Okay. So let's give ourselves a line 5/16 over. These are just lines to help visualize. So let's take our object and let's rotate it. Select the base point, which is going to be right here. Now let's rotate that. Okay, so that's definitely going to be problematic. Meaning, you can see that it's going to hit. If we took and flushed the pivot, this edge all the way to the backside, it's not going to work. Let's take our pivot point. This is why we grouped the object. Rotate. Let's bring our pivot point out. .3/16 out. That means 1 1/8 in. So that could quite theoretically work because we don't get past there. If they were to open both of them at the same time at the same moment, that could be 3/16 in. So we're going to just have a little bit of the knuckle hanging out. Let's put the pivot point right on the outside face. So right here. Yeah, that'd be no problem at all. In fact, you can see that it doesn't interfere with anything whatsoever. So the problem, though, is we're not getting in far enough. That's 1 5/16. You're going to be mortising to the tambour board at that point. So let's imagine that our... I'm going to draw in this. 4 3/8 wide, 4 3/8 by 5/8. Let's draw that in. Let's just put that at right here. So 5/8. Then we're going to go 4 3/8. Okay, that's where we want our pivot hardware to be. The issue, though, is if that's where we place it. Let's say that we can actually cheat this ever so slightly. Maybe. Gosh, maybe 3/16. Meaning this is what I've drawn here. Let's say that we cheat at 3/16. It's only 5/8. 3/16 times 2 is 3/8. That's going to leave 2/8 or 1/4 inch. Let's just say the max you can cheat it is 3/16. So let's take and group that so we can move it all as one unit. Now we've cheated it down 3/16. That's our bottom pivot, actually. So 5/8, 1 1/4. So let's do this. Let's take this. Let's ungroup it. Let's add 1 1/4 inch. Oh. Yeah, it's 5/8. Okay, so now let's go in 5/16. Now we've got it cheated 5/16. We've got it cheated 3/16. And let's actually do one more nice little thing here. Sorry. Let's ungroup this. I want to make it look a little more realistic. Let's bring another circle with a 0.3125 radius. There it is. Let's trim. Trim. Great. Let's group. Let's move it. Okay, now we have that cheated down. Let's get rid of some of the extraneous that we no longer need. Let's rotate our door around that base point. But let's do the so that this line is going to represent the veneer core, the 3/4. So yeah, you're cheating out into the bottom, into the tambour board slightly underneath. But I think your screw holes are still going to be in solid veneer core. So I would say that this is going to work. Let's clean up a couple of smaller doodads. Yeah. Yeah, the actually, if you'll forgive, well, yeah. So a couple of things are happening here that we're discovering. We're going to be good on this side. We're not going to hit over here. If you cheat it out to get that right underneath the veneer core, you'll be in good shape. However, look what's happening over here. So the doors are going to need a relief or a bevel. Probably a 3-degree bevel would be plenty over here. So he'll have to bevel that side. I mean, what I should have done was obviously I should mirror this and then copy it, and we can move all of them.
AB Supply, this is Terry.
Okay. Okay, so I've got some things flipped around and moved around the bottom line. So we have an 1/8 of an inch margin between the two doors. So what I'll do is let's grab the first one and let's rotate it, the first door I should say, and then we'll select our base point here. Get it about halfway open. Then let's rotate the second door, select that base point. And when I mean half open, I mean half of the thickness. Let's group our object. Yeah, definitely going to have some conflict here. It's not much, but there's going to be some. So putting a little bit of a relief on the two doors will be necessary for the client, meaning a bevel, so that what he's doing is actually going to need to look, and I won't bother re-rotating it, even though it'd be no work to do so, but yeah, so 2-inch 87 degree of just figuring on a 3-degree bevel. Okay. So in no instance are our doors ever really going to hit. You know, I've got the one door open ajar. If we put a 3-degree bevel on both of them, we're going to have more than 1/8 of an inch. So the client can certainly do a 3-degree bevel without any trouble at all and be in real good shape there. Yeah, so there you go. That is what I would end up doing, meaning I would cheat in 3/16 under the tambour board, mortising it all flush. It'll give me a good pivot point. I will have to relieve the outside, the leading edges a little bit. You won't see that from the exterior at all. No need to bullnose, no need to radius. You're only going to have 3/16 projecting off the face. That's a tiny amount of projection to see off the face of these doors. It's going to look really, really great. So the client's obviously doing so that's the client's project right there. Awesome. Looks really good. Okay, thank you very much.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.